Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's work on our homework, or take a look at our homework, problems 59 through 63. Our task was to graph each one of these rules without using a table, using the shortcut that we learned about with this rule y equals mx plus b. So for each one of these, it's good for us to identify what is the m and what is the b. In this case, the m is whatever is being multiplied times x, so that would be 2, and the b is whatever is being added on at the end, and if it's subtracted, we'll call it a negative, right? So that would be 2x plus a negative 3 if we put it into an addition problem, but it's a subtraction, but still, that negative sign or that minus sign is attached to the 3 as a negative. So for graph A, we're going to start where we have 0, negative 3, that's your y-intercept, and it should grow by 2, so it's going to go 2, 1 to the right, 2, 1 to the right, 2, 1 to the right, 2, 1 to the right. And I did not label each one of those points because I didn't want the labels to run into our growth triangle. So that's why I don't have any of these labeled. For this one, our slope is equal to negative 2 and our y-intercept is at 5. So we'll go to 5 and then go down 2, 1 to the right, down 2, 1 to the right, down 2, 1 to the right, down 2, 1 to the right. Remember, the m is what we call the rise over the run. It is how much does y change over how much does x change. In this case, it's going to be negative 2 over 1, and in this case, it's going to be positive 2 over 1, right? We don't need to put 1 in the denominator because it's implied, but if we have a fraction, like in this one, we would want the 1 in the numerator and whatever the denominator is, right? So our slope or our growth rate is a fraction. It's just sometimes the fraction's denominator is 1, so we don't bother writing it in. Like this one, where our slope would be 3 over 1, but our y-intercept has to be 0 because there's nothing being added on the end. So we would start here, and then we would go up 3, 1 to the right, up 3, 1 to the right, up 3, 1 to the right. Or you can view it as going down 3, 1 to the left, because look what happens here. If you said the slope was negative 3 over negative 1, two negatives make a positive, right? Negative 3 divided by negative 1 is positive 3. So you could start here and go down and 1 to the left. Going to the left would be a negative direction. So depending on the direction that you're going, you could have them both be positives or both be negatives. And in this case, you could start here and you could go 2, but then you would go 1 to the left, which would be like a negative 1. And then for the last one, our slope ratio is 1 over 2, and we start with a y-intercept of 1. So we're going to start here and then go up 1 to the right, up 1 to the right, up 1 to the right, and that gives us our line. And it takes you a fraction of the time as opposed to setting up the table and coming up with all these ordered pairs and then plotting all of the ordered pairs in their proper location. It's a good idea to use those tables, but once you understand how all of this works, this is much more efficient, much faster. All right, so examine the graph below, which displays 3 tile patterns. You got pattern A, pattern B, and pattern C. So I'm just going to look at each one of these. Notice how both A and C start at 0. So their starting point is at 0, and then they have this one, graph C, has a faster growth rate than A. And B starts at 30, and this one is actually having tiles removed as you go from figure number to figure number. So which of the what do you know about figure 0 for each of the 3 patterns? A and C have 0 tiles, and B has 30 tiles. Which pattern changes more quickly? All right, so that's a tricky question, because someone might think that A is quicker than B, because this one is going in the positive direction and this is going in the negative direction. But you're kind of thinking about absolute value here. How much does it change? And so it looks, I can't really tell what the pattern of growth is for line A because they're not giving us any clear points there. But B and C, we can figure that out. For graph C, this increased by 10 tiles per figure, right? That's terrible writing, but you get the idea. It went up 10, 1 to the right. Went up 20 for 2 to the right. So that's 10 tiles per figure. B went down 10 when it went 2 to the right. So this one goes down by 5 every single time. So the rate of change, this is changing by 10 every figure. This one is changing by 5, even though it's going down. So C does have the quickest change. And then which figure has the same number of tiles in pattern B and C? That would be figure 2 is 20, right? So they share this point. And then what is the rule for pattern B? Well, pattern B starts at 30, so the y-intercept is at 30, and it changes at a rate of 5 tiles per figure number. So that would be the growth rate. So y equals negative 5x plus 30. So you can tell when you're going to run out of tiles for B, because that would have to be 6, right? Negative 5 times 6 would be negative 30. And when this is negative 30, you add it to the positive 30, you would get 0 for the number of tiles for y. So in the 6th figure, there will be no more tiles in pattern B. They didn't ask us that. I'm just throwing that in as a bonus. All right, translate these algebraic statements into words. Y equals 2x plus 5 and y equals 6x plus 5. What do you know about figure 0 for each one? Well, they each have 5 tiles in the starting figure 0. They both start with 5 tiles. Which pattern grows more quickly? Well, this one does. It's growing by 6 tiles per figure, whereas this one is only growing by 2 tiles per figure. So, translate these algebraic statements into words. Y is equal to 2 times whatever x is plus 5. And yeah, I don't like that. Whatever. This is the more important stuff right there. All right. Changing the subject completely. Find the area and perimeter of each shape. So in this one, I would probably do this. I'm going to break this guy down into 3 different rectangles and find their areas. Stop it. Find their areas. And then figure out what the perimeters are. So this one is a 2 by 12. 2 times 12 equals 24 square centimeters. This one is 5 by, what is that? What is this? If that's 3, that's going to be 3, and this is 9, so this has to be 6. This has to be a 6 by 5 to give us 30 square centimeters. And this one, what does this have to be? If this is 7 and this is 5, and this has to be 2. So that's going to be a 2 by 9, which is 18 square centimeters. So add these up, 24, 54, 64, 72. The area is 72 square centimeters for all of those combined. Now for the perimeter. That's 12, that's 2, that's 3, that's 5. This has to be 3 also. And we decided if this was 7 and that's 5, this must be 2, right? Those combined make 7. This is 9, this is 7. What does this have to be? If this is 3, no, if this is 9 and that's 12, then this has to be 3. So we're just going to add all these together. So this is 5, 10, 15, 20, 32, 39, and 39 plus 9 is 48. So the perimeter is 48. All right. Pac-Man. We need to know 2 formulas here. We need to know that area is equal to pi times the radius squared. And we also need to recognize that this is 3/4 of a circle. So if I find out the area here, I have to find what 3/4 or 75% of that is. Let's do that. The radius is 4. So this is going to be 16 times pi, right? So it's 4 squared is 16. And I'm going to take 16 times pi, That gives me 50 point blah, 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 blah. And now I'm going to take 75% of that by multiplying that times 0.75. And that's how I get 37 point. Ooh, you know what I bet I did there? I bet I multiplied this times 3.14. So I would probably round that to 37.7 anyway. Maybe that's a better answer. 37.7 works just fine. And then the perimeter, we're going to have to find the circumference first. And this part right here represents 3/4 of the circumference, but that's not where it ends. We also have to add this 4-inch and this 4-inch. So let's find the circumference, which is pi times the diameter. So that's going to be 8 times pi. I'll take 3/4 of that. 8 times pi equals this. Now I'll take 3/4 of that by multiplying times 0.75. And that is 18. That's going to be about 18.85 or 18.84. And now add 8 to that, plus 8. So if you said 26.85 instead of 26.84, that's probably more accurate than this one. I guarantee you I did 3.14 here instead of multiplying times pi on the scientific calculator. Either way, those are the areas and the perimeters for these two problems. And now this is the last problem, I'm pretty sure. Ms. B is making snickerdoodle cookies. Her recipe uses 1.5 teaspoons of cinnamon to make 2 dozen cookies. If she needs to make 13 dozen, give 1 cookie to each of her students, how much cinnamon will she need? All right, so this is the rate, 1.5 teaspoons for every 2 dozen. So what are we going to do here? Do we multiply 2 times 6.5? So I'm going to multiply that times 6.5. That would work, since 2 times 6.5 is 13. Let's see what we get. 1.5 times 6.5 gives us 9.75. So that's 9 3/4. Okay. So then, if we're going to figure out how many tablespoons and teaspoons she would need, oh, that's horrible. Why would you even ask that question? Oh, okay, here we go. 3 teaspoons is in 1 tablespoon. So every one of these teaspoons, if we get 3 of them, you get 3 tablespoons. So that's all I'm going to do. I'm just going to say you take 3 tablespoons, because for every 1 tablespoon, it's 3 teaspoons, and you got 9 of them. So I think you can follow along with that. So not 3 tablespoons and 3/4 of a teaspoon. And there you go. We are done. I'm certain of it. Yes, we are. All right. What time did that? Oh, that was a little bit longer. All right. So let's wrap this up and move on to our next activity. Bye. Bye.
Hey, feeling good.